Welcome to The Explainer. So today, we're going to build a mental map of programming right from the ground up. We're going to demystify all those core pieces of software and give you a really simple, clear framework that'll guide you on your learning journey.
All right, so here's our game plan. We're going to start with the absolute basics. How does a program remember even one single thing? From there, we'll see how it can act on that info, how it makes decisions, then how it can juggle huge amounts of data, and finally, how it saves everything. It's a really logical path from one tiny idea to a whole program.
So first things first, before a program can do anything interesting at all, it has to be able to remember information. And that's where two absolutely fundamental ideas come into play: variables and data types. The secret? It's a simple but really powerful concept called a variable. Honestly, the best way to picture it is just as a labeled box. You give the box a name, you put a piece of information inside, and that's it. This one idea is the foundation for everything else we're going to talk about. Okay, so what kind of information can we actually put in these boxes? Well, the most basic type is an integer. These are just your normal everyday whole numbers. No fractions, no decimals, just simple solid numbers like 42 or, -3. But what if you need more precision? Like, what if you're dealing with money or maybe some scientific measurements? That is where floats come in. A float is just any number that has a decimal point. So think pi, 3.14, or half, zero point 0.5.
Now, programs handle text using something called a string. It's basically any sequence of characters you can think of, wrapped up in quotation marks. But here's a really critical detail, and it trips up a lot of beginners. If you put numbers inside quotes, like 123, the program sees it as text, not a number. You can't do math with it. And finally, we have the simplest, but you could argue it's the most powerful data type of all, the Boolean. It could only ever be one of two things: true or false, on or off, yes or no. This simple little concept is the absolute bedrock of all decision-making in every single computer program you've ever used. Great, so we've got our labeled boxes and they're full of data. But just storing it is kind of boring, right? Now it's time to make our code actually do something with that data. And we do that using operators and functions. Operators are pretty much just the symbols we use for math. You know most of these already, like addition and multiplication. But check out that last one, the modulus operator, that percent sign. This thing is a super useful tool. It doesn't give you the result of a division, it gives you the remainder. So 7 divided by 3 is 2, with a remainder of 1. Modulus gives you that 1. It's the secret trick programmers use all the time to figure out if a number is even or odd. Now, functions are like these pre-built tools that do a specific job for you. For instance, the print function, well, it prints information to the screen. The input function lets us get information from a user. And here's a huge takeaway for every beginner. Input always gives you back a string, even if the user types in a number. You have to tell the computer to convert it if you want to do any math with it. Okay, this is where things get really cool. We've stored data, we've acted on it, and now we're going to give our code a brain. We are going to teach it how to make decisions all by itself, based on the data it has. We do this with if statements, and the difference you see on this slide is so important. If you use a bunch of separate if statements, the computer checks every single one no matter what. But if you use if elif, which just means else if, it stops the second it finds a condition that's true. This isn't just about being more efficient, it actually guarantees only one thing happens, which helps you avoid all sorts of weird bugs. So, what on earth happens when you run into a monster of a condition like this? I mean, it looks completely overwhelming. You've got and, you've got or, you've got not, but there's a really simple secret to solving it in an instant. Here's how you break it down. Just like in math class, programming has an order of operations. Python always looks at the and parts before it looks at the or parts. So that whole complicated mess on the left, it all gets boiled down to one single result, either true or false, and then it gets compared with or true. And here's the punchline: it doesn't matter what that result is. In the world of logic, if you have any condition, could be true, could be false, doesn't matter, and you say or true, the entire thing becomes true. That little or true at the very end is a shortcut that makes this whole line of code evaluate to true every single time, no matter what A, B, or C are. All right, We're getting good at handling one piece of data at a time. But what happens when you need to process, say, 1,000 usernames or 1,000,000 data points from an experiment? Writing 1,000,000 variables is just not going to work. We need better tools for this. And those tools are lists and loops.
A list is pretty much what it sounds like. It's a single variable that holds a whole collection of items in a very specific order. I like to think of it as a shelf with numbered slots. But, and this is one of the biggest hurdles for new programmers, the numbering doesn't start at 1. It starts at 0. So the very first item on your shelf is always in slot 0. So if a list is the shelf holding all our items, a loop is like the factory conveyor belt. It takes that whole collection and processes them one by one, running the exact same block of code on each item until it gets to the end. This is how you automate repetitive tasks and work with massive amounts of data without losing your mind. Okay, for our final section, we're going to level up how we organize our data. And just as importantly, we're going to see how we can make it stick around even after our program has stopped running. Let's talk about dictionaries and files. This slide really gets to the heart of a key difference. A list, remember, is like that numbered shelf. You ask for item 0, item 1, and so on. A dictionary, on the other hand, is more like a phone book. You don't ask for the 50th entry. You look up a name, we call that a key, to get the information, we call that the value. It's often a much more natural way to structure your data. But none of this data matters if it just vanishes when you close the program. To make it permanent, we write it to a file. The safest way to do this is with the with open command, because it automatically handles opening and closing for you. But, and this is a huge warning, you have to pay very close attention to that little W. That W stands for write mode, but you should really think of it as wipe mode. It will completely erase anything and everything that was already in that file before it starts writing. And this all brings us to a few key things to watch out for. We've talked about some of these already, right? Input always giving you text, using a single equals sign for assignment when you meant to use a double equals for comparison, and that tricky list index starting at 0. Seriously, avoiding these common traps will save you hours of headaches. So there you have it. Look how far we've come. In just a few minutes, we've gone from storing a single number to making decisions to handling huge amounts of data and even saving it permanently. We've built a complete mental map of the fundamentals. You now have the core building blocks to create something amazing. So really, the only question left is, what are you going to build first?